Okay, so today we're going to be talking about really cool stuff. Who's ready for cool stuff? Yay! All right. Fire, water, earth, and air. So these are real images from what happened at Cyclone Alfred. So who got affected by Cyclone Alfred? Any Queenslanders here? Yeah, quite a few of you. Now, have a think about what could potentially help before, during, and after a disaster like Cyclone Alfred, right? And hint, it's not a Pokemon. It's actually a drone. So let's dive into how drones can help before a disaster. So you've got here preventative maintenance. So drones can help with assessing where there's potential damage so we can prevent some of these catastrophic damages that you can see in these bridges here. And what about during a disaster? Drones can go where no human or vehicles can go. And lastly, after a disaster, drones can help assess the damage for insurance and risk purposes. Because if I was a bridge inspector, I certainly don't want to be around any of these bridges here. Hello, I'm Nishitani. I am a Director of Enterprise Architecture at NTT Data. And I might look familiar to you because I used to be at AWS as a Senior Solutions Architect. Now, the number one question that I get coming over to this side is, what is NTT? What do we do? So we do everything from all the way from undersea cables, so think about internet connectivity across the Pacific, all the way up to space. So we do satellites and 5G connectivity. Now, you might be wondering, what's that emoji in the middle? And who's used an emoji before? Yay, quite a few of you. So you might be surprised to learn that NTT Docomo, who is our mobile services arm of our organisation, actually created the emoji back in 1999. So we do a lot of research and development work, as well as a full stack provider across advisory all the way up to implementation on cloud, network, security, traditional data centres, and data and AI as well. So being at an AWS Community Day, what do we do with Amazon and AWS? Who's heard of Project Kuiper? Yay, awesome. So Project Kuiper provides satellites in order for remote areas to have internet connectivity. And NTT were the first to collaborate with Project Kuiper back in 2023 to provide that connectivity across Japan. And we also have our own Gen AI Tech Hub, so we can accelerate development and deployment of Gen AI services like Amazon Bedrock and Bedrock knowledge bases, as an example. But we are cloud agnostic, so we can do that across other hyperscalers and Databricks and Snowflake as well. Now, let's move on to the stars of the show. So our drones, we configure ourselves and we can provide for public usage. And they're categorized into two separate areas. And one of them is the aerial photography drones, which are the Anafi drones, and the inspection drones, which are the Skydio drones. And all of them come equipped with 4K cameras. And with the inspection drones, we have 360-degree object avoidance and autonomous flight as well. So we can set them on the way in order to do some inspection work. And we have LiDAR and thermal capability as well. So instead of just talking about it, let's take a look at our drones in action. So you might be looking at this and going, wow, what a peaceful scenery with waterfalls and stuff. But as our drone takes a look at what's happening behind the scenes, you can see debris all over the place. And that's because this is a real disaster that happened in Japan, in the Yamagata prefecture. And you can see the drone here looking at the road there that's been blocked by a bunch of debris. It was an actual landslide. And there's actually a bridge underneath there. So imagine trying to get to that place to assess the damage as, let's say, a bridge inspector. It's got to be quite impossible. So drones are doing the good work here. Yeah, you can see the tree roots and everything uprooted, which isn't really great. Now, we're going to switch to another disaster here, which is a landslide event after rainfall. Now, you might see our drones taking off, and in just a second, you'll see a cable there. So who can guess what this cable might be? It's a fibre optic cable. So what the drones are doing is restoring internet in times of need. And it might be difficult for humans to get out there, so the drones are restoring internet connectivity. Who's had flaky internet connectivity recently, especially after rain? Yeah. So drones are doing the good work of making sure that everyone's connected, especially during disasters. And now we're going to switch to the water element in just a second. So this is a real fishing pier in Japan, and our Skydio 2 Plus drone is doing some routine bridge inspections. Now, as you can see, this bridge isn't connected to land. So unless, there's a device that lets humans walk on water, maybe call Jesus, but if you had to manually inspect it, you have to take out a boat, and you've got to make sure that you retain that distance, especially if you're collecting data to assess the state of the bridge. So what our Skydio drone is doing is looking out for any cracks or rust across this bridge. And we've collected thousands of hours of images from our drones and trained our own proprietary machine learning model that can output some useful data for our customers to use. Now, here's another instance of underneath the bridge. So what our drone's looking out for is the rust. You can see the orange parts, that's the rust and the corrosion. So again, doing some routine inspections to collect any potential damage that could have a catastrophic effect on our infrastructure. And you can tell that this is not a disaster, but this is a culturally significant house. And what our drone is doing is mapping out the internals of our significant house. And it's collecting information in order to create a digital twin on the metaverse. So you can actually visit this house on the metaverse without leaving the comfort of your own home. So drones are doing some culturally significant work and leaving that legacy for future generations. Now, speaking of the 4 elements, and back to the fire element in just a second. Now, as we lead up to summer, we're coming up to bushfire season. So let's take a look at our drones helping firefighters. So this is a real forest fire happening in Japan, and our drone is assessing where the fire has spread to. And it's difficult for some firefighters to get to the core of the fire because it's unsafe for even firefighters to get to. So it's not only assessing the scenery, it's also trying to extinguish the fire with the right water balance as well. Now, you saw our drones in action, and this is a real use case. A customer came up to us and said, hey, we've got our own drones, we've got our own drone images, but we don't know what to do with it. Because at the moment, people are actually looking at our images manually, and it's taking time in order to do some inspection or maintenance, routine inspection. So can you help us make sense of our drone images? Maybe you might be able to detect rust or cracks. So let's take an example of an image, right? This is a concrete bridge. It looks like any old concrete bridge to me. I'm not a bridge inspector. I wouldn't know if there's any damage to that bridge. But with our proprietary machine learning model, it's able to output some of the defects across this particular bridge. So it picks up any rust or cracks. It also outputs the CSV data with the XY coordinates, as you can see, and the width of each of the defects here. And lastly, the DXF file, which is the CAD data that goes along with it. So how do we present this back to the customer in a meaningful manner using AWS? So we're always going to start off with the drone image, and we're going to put that through into our NTT proprietary machine learning model. And from there, it'll output some files, and we're going to store them into Amazon S3, which is our object storage service. And from there, we're going to trigger a Lambda function, which triggers Amazon Bedrock, which is our generative AI service. Now, I've given Amazon Bedrock a prompt. I said, look, Claude model, the latest model out there. I said, hey, look, can you pretend that you're a bridge engineer and tell me, based on the data that we've inputted into S3, whether that constitutes a low risk, medium risk, or high risk in terms of the overall status of the bridge. Can you tell me what are the next recommended actions, right? Do we need repairs straight away? How much is that going to cost? Now from there, another Lambda function triggers, and we're going to update our dashboard, which is a React dashboard hosted on AWS Amplify. And from an engineer perspective, you'll be manually coding with the help of Kiro, which is our agentic AI code generation tool, which is spec-driven development. You saw in the previous session before about Kiro, but we'll see Kiro in action in just a second. Now, from an engineer standpoint, we'll be updating the code via CloudFormation and updating our Amplify hosted React dashboard. From a user perspective, we'll be using single sign-on, and we'll have different levels of access. You might have read-only, read-write, based on what persona you are. So if you're, let's say, a bridge engineer, you just need read-only access, you can do that through Cognito. Maybe you're an administrator and you need to administer all the users on that particular dashboard. You can do that as an admin level person. So let's go ahead and check out what that looks like from a user perspective. So I've dedicated this dashboard to Brisbane. So you might actually see some real Brisbane bridges in here. So let's say I don't have an account yet, so I can sign in using Cognito's sign up functionality. But I already have an account, so I'm just going to log in with my own user email address and password. And you're going to see a lot of Brisbane bridges here. Now, don't be alarmed if you see the Story Bridge in red, because this is demo purposes only, right? And I've logged in as a viewer mode, so read-only at the moment. And as you can see, we've got 10 bridges on this dashboard. Traffic light system, critical is red, medium is yellow, and low risk in green, easy to understand. And I can also go to the left-hand side around each of the panels and each of the bridges and filter according to the bridge name or the criticality of the bridge as well. So who's heard of the Story Bridge before? Yeah, awesome, awesome. Brisbane represent. So, this is actually good in terms of, like, if you're a drone engineer, you want to have your drone autonomously navigate through which ones are the critical bridges first, and then go to the less critical bridges later. So flight path automation, that kind of thing might be good. And on the right-hand side, you'd see the actual map of Brisbane, and you can filter down according to the criticality level as well. And let's take a look at one of the bridges in red, which is the Captain Cook Bridge. So we're just going to dive into what that looks like. Now, once we're in there, it gives you the overview of the health status, as well as, what are the number of defects that are detected within that bridge, and what's the maximum width of each of the cracks that are detected here, and who inspected, and when was the bridge last inspected by humans? You still need a human in the loop as well. And you can look at the distribution of each of the cracks on the bridge. In this case, is it low, moderate, or critical? And you can also see the health score trend over time. Has it degraded in terms of the health status? And is there need to be taking action for that particular bridge? Now let's dive into each of the cracks as well, because we want to make sure that if we're taking some routine maintenance, we want to make sure that we're repairing the right defect there. So you can see the crack width distribution all the way from maximum, the average length, all the way up to the minimum length. as well. And the total number of cracks, the number of critical cracks, and what to look out for. And you can also scroll down to see which of these defects need attention. So there's different severities, high, medium, low, and what are some of the actions that are required. Okay, we talked about the human in the loop. We definitely can't get rid of bridge inspectors because, they are the ones that have been doing the work historically, and they can actually log their manual inspection dates and the details here. And this is where Amazon Bedrock comes into play and providing that recommendation based on that prompt that I gave. So what are the recommended maintenance actions that needed to be taken in the low, medium, and high risk scenarios, and short-term to long-term repairs, right? So it even comes up with the recommended repair costs as well. Now you saw the front end and the user perspective. Now let's dive in behind the scenes with Kiro as an engineer. So what does that look like building out this solution? So I gave Kiro a prompt and I said, hey, look, I've already created the integration with our dashboard and Cognito, but let's say I still haven't integrated S3 yet. So I've given Kiro the instruction of let's integrate S3, can you help me out? So it came up with an actual specification or the requirements, right? And as you can see, it came up with some user stories. Now, the benefit of this is that it comes up with each of the user profiles or stories, like, for example, bridge engineer, bridge inspector, maintenance coordinator, and also a systems administrator. And it comes up with acceptance criteria for each of these personas. Now, who's had problems gathering requirements in a project? Yeah, so that's the most time-consuming part. The tech is the easy part, is getting information out of people. That's really difficult. So Kiro can help you in lessening that time in order to get all the requirements together. But that's not to say it's a replacement for product owners or anyone else gathering requirements. It makes your role a 10x engineer, product owner, or an architect. And you can always start from here and continue to add or edit as you need. Yeah, I certainly had problems even as an architect, even getting the right people in the right room. They don't know what they want, right? And that typically happens across projects. So, okay, so let's say I'm happy with those requirements. I told Kiro that's all good. Now, the next step is building out that design document, right? And again, that's the complexity around that. And who likes updating documentation? Yeah, one person. Yeah, so now with the documentation and the design document, I'm looking at the S3 service layer for the interactive layer, the synchronization service. I'm also looking at the security aspect of it with signed URLs, etc., and authentication. So I've seen on a number of projects that people push security till last because, they're busy. They want to get stuff working, right? But Kiro already has security in mind. Now, you can see the overview. It creates the high-level architecture, as you can see. So it takes the guesswork out and the time-consuming effort of looking at AWS reference architecture and using your knowledge and all of the above, and also the data flow as well. So that often gets missed, as well as the code snippets. And it updates not only the foundational documentation, but Kiro can also continue to update your documentation depending on if there's any manual code changes or even automated code changes from Kiro. So it takes out the guesswork and having to remember updating the areas of documentation. It even comes up with a data model. And the great thing is that it even looks at error handling as well. And again, error handling, graceful degradation, and who's done a well-architected review recently? it always gets missed, right? The graceful degradation aspect of it. Security considerations around your IAM policies, signed URL configuration as well, data protection, right? So especially if you work in a regulated environment, these areas are going to be scrutinized. Now, this is where I'm creating an agent hook, where with just 2 clicks, I can get Kiro to continuously monitor my Git repo for any changes, and our agent can update my documentation automatically. So if I'm happy with that natural prompt, I can just click enter, and Kiro will do the rest of the work, right? So super handy. And just while it's doing this, I also wanted to mention Kiro can do integration with your favorite MCP server as well. And we'll take a look at that in just a second. So you can be the agents of agents of agents, and it continues on, right? So the hook's created, and we're just going to have a look at the mcp.json file just for fun. So this is where you can configure your MCP service if you wanted to. So really handy. Kiro's thought about the further automation with agents. Okay, so let's see how our documentation is doing in the final format. So we came up with a high-level overview and high-level architecture, including all the components, so the core AWS services, including what the purpose is for as well so far. And now being in partner land, I've been tasked with documenting a lot of these, what's our solution look like, what does it consist of, what does it do? So it does definitely take out the heavy lifting of continual documentation and updating. Even the data flow architecture as well, right? This is the complex part of how does that data go from S3 all the way back to the user, and the S3 bucket structure as well as the security architecture. So you saw from all the way from a front-end perspective as a user and from an engineer perspective with Kiro. And what we're thinking for the future of our solution, we're definitely thinking of leveraging the 5G connectivity capability that we have with our network, and potentially Kuiper in the future, and being able to use AWS services in order to scale and provide that real-time predictive maintenance aspect. And also integrate with other corporate systems like GIS for spatial integration, and also SAP, for example. Now, we can leverage our LiDAR and thermal capability in order to get that comprehensive analysis, and we can scale out not just around Australia and Japan, but around the globe. Now, this is what it looks like in terms of the pattern in the future. Again, starting off with our drone images, we might be able to leverage AWS Marketplace in order to install the cut-down version of our ML model on the drone, and then leveraging 5G connectivity in order to stream that data via Kinesis into Amazon S3. And then from a customer standpoint, they might be able to use SageMaker AI in order to continue to train their own images as well. And from a user perspective, if you wanted access to the raw data, you can use AWS Transfer Family and the web portal feature to safely and securely download raw images. And from a system standpoint, we can integrate via S3 into other systems like GIS that we talked about. Now, it won't be a community day without talking about what NTT does for the community with our NTT eDrone School. So our eDrone School provides capability around improving drone engineering skills for the general public and high school students as well. And it's co-located with real programming classes, so you can really get your hands dirty the old-fashioned way. Now, what are the key takeaways from today? So we used all AWS native services in order to scale, the community impact in terms of real disaster recovery, and being able to provide those drone engineering skills for the future, and the practical implementation, right? So how do you start with a drone image analysis proof of concept, start small. And cost effectiveness, we used AWS's economies of scale, including marketplace, and scalability. So how do we scale using AWS globally? So if you want to talk to me about an image analysis proof of concept, I'm in the golden jacket, you can't miss me. Come chat to me, or you can check out the NTT eDrone Technology YouTube channel to check out the drones. And with that, thank you for listening and keep on droning.